Alright, in this screencast, we're going to learn about Charles' Law. And Charles' Law is an experiment kind of like these two flasks. And in the flask over here on the right, this one contains air that was room temperature probably. And you can see that the balloon is outside of the flask and there is gas inside. And in the flask on the left, what has happened is this flask has been put into an ice water bath, and the air that was in this flask got colder, and you can see that it reduced in volume and sucked the balloon inside as the volume shrank. All right, Charles' Law is an investigation of volume and temperature. So these are the two variables that are changing. And you also have pressure and moles are constant. You're not allowed to change those. So if we look at this image on the side here, we can see that in this first canister, we have a temperature of -65 and we have this much gas. And on the right, you have 250 Celsius and you have this much gas. So what has happened from the left side is you went from a cold temperature to a higher temperature, and you can see that the amount of gas has increased. All right, so we have volume and temperature, and in the images that we've looked at, we've seen that as volume goes up, the temperature goes up, and vice versa happens as well. Remember that the pressure and the moles are constant, okay? So they are not changing. So our equation is going to be V1 over T1 equals V2 over T2. And as long as our volumes have agreeing units, that's fine. But for temperature, our temperature has to be in Kelvin. Here's the deal. A common temperature in our everyday world is 0 Celsius. And if you were to put 0 into this equation here, you would not be able to calculate a value. So you can't have negative numbers and you can't have 0, so our normal Celsius scale is lacking. So we need to convert to Kelvin in order to be able to avoid negative and 0. So Kelvin is equal to 273.15 plus the Celsius. Okay, so it is critical, absolutely critical, that you change all your temperatures into Kelvin or you will get a wrong answer. And in truth, if you think about it, going from 20 to 40 Celsius might seem like it's doubling, but if you're talking about 293 to 313, that's not doubling. All right, here's your sample problem. It says a container of nitrogen gas is at 25 liters at STP. What is the volume if the temperature is changed to 30 degrees Celsius? So our V1 in this problem is 25 liters. T1 is embedded in STP, so STP stands for 273 Kelvin. Our second volume is what we're looking for, and our second temperature is given to us as 30 Celsius. So we have to change that by adding 273, and so we get 303 Kelvin. Okay, so as we plug these in, you have 25 over 273 equals V2 over 303. Now, when you're solving these, you're going to want to cross multiply. So what we are going to end up doing is taking the 25 times the 303, and that will equal to the 273 times our V2. Okay, and you will multiply this side, and you will then divide by this number. And so when you do that, you get an end answer of V2 is 27.7 liters. Now, if you were rounding to sig figs, you would go ahead and call that 28 liters. All right, so this one is your homework. I would like you to submit the answer and your work to this problem into the Schoology assignment for Charles' Law, because that's what we're working on. So you're going to need to solve this problem, set it up and solve it, and submit it for homework. So the problem says a container of carbon dioxide gas at 25 liters at STP. There it is again. What is the temperature if the volume is changed to 84 liters? Okay, so you're solving for T2. I need you to set this up and submit it into the Charles Law Homework in Schoology.